Welcome to all. In the previous classes, we have discussed mean, median, mode as different measures of central tendency. Next, our interest is geometric mean and harmonic mean. First, geometric mean. What is geometric mean? How to find geometric mean? Geometric mean of a set of n values or observations is the nth root of the product of the values or observations. Nth root of the product of the values. For example, we have x1, x2, etc. xn are n observations. x1, x2, etc. xn are n observations. Then geometric mean can be defined as nth root of the product of x1, x2, etc. xn. That is x1 into x2 into etc. xn into xn, the whole raised to 1 by n. Or simply product I equal to 1 to n xi, the whole raised to 1 by n. For a grouped data, in the sense a grouped frequency distribution or a continuous frequency distribution, there we consider in the discrete case we have discrete values x1, x2, etc. xk for example. And if there are class intervals, so you can find the midpoints as x1, x2, etc. xk. So that the corresponding frequency f1, f2, etc. fk. So xi is the ith class, the observation, the midpoint of the ith class xi. The corresponding frequency is fi. So xi raised to fi, product xi raised to fi, where I equal to 1 to k, the whole raised to 1 by n, whole raised to 1 by n, whole raised to 1 by n. This is the geometry mean. So x1 raised to f1, x2 raised to f2, etc. xn raised to fn, the product. So x1 raised to f1 into x2 raised to f2, etc. xn raised to fn, xk raised to fk. Here, since we have k classes, the whole raised to 1 by n, where 1 by n, capital N, is the total frequency or total number of observations. Capital N is the total number of observations. Let us consider some examples to illustrate these concepts. Once we have a raw data, say here are 3 data points, 2, 8, 32. Then geometric mean is the product of these numbers, 2 into 8 into 32, whole raised to 1 by 3, because there are 3 observations. So all raised to 1 by 3. So cube root of 2 into 8 into 32. That is nothing but 8. So so geometric mean is 8. Similarly, for a discrete data, we have discrete data points xi, 2, 4, 8 are the points, and fi, the corresponding frequencies 2, 3, 1. Then geometric mean is 2 raised to 2, this 2 raised to 2, the corresponding frequency, into 4 raised to 3, it's the corresponding frequency, into 8 raised to 1, the whole raised to 2 plus 1 by 2 plus 3 plus 1, that is 1 by 6. So this is the geometry, which is on computer. Let us compute it, find it. We can see that it is 3.56. You can use scientific calculators if needed for evaluating this, or otherwise logarithmic tables also we can utilize. Now once we have a continuous frequency distribution, say the class intervals or the class here 0 to 10, 10 to 20, 20 to 30, with the corresponding frequency 4, 6, 5. You can find the, first we can obtain the midpoints. 0 plus 10 by 2, that is 5 in the case of the first class. Next case, 10 plus 20 by 2, that is 15. Third case, 20 plus 30 by 2, that is 25. Now, geometric mean can be obtained as 5 raised to the first midpoint, 5 raised to 4 into 15 raised to the second midpoint, 15 raised to 6 into 25 raised to 5, this 5, the whole raised to 1 by 15. 1 by 15 means 6 plus 4 plus 6 plus 5, that is 15. That is 1 by 15. So you can compute the value and thereby we get it as 13.27. 13.27. So geometric mean is 13.27. Next, harmonic mean. What is harmonic mean? Harmonic mean is the reciprocal of the arithmetic mean of the reciprocals of the data values. So once we have x1, x2, etc., xn, so you take the reciprocals 1 by x1, 1 by x2, etc., 1 by xn, take the sum and use this formula. So we have n values, so n divided by summation I equal to 1 to n 1 by xi. So that 1 by x1 n by 1 by x1 plus 1 by x2 plus etc. plus 1 by xn in case of a raw data. And for a grouped frequency data or frequency distribution or grouped data, harmonic mean there are frequencies. So if there is classes, you can find the midpoints are there. If discrete points, you have this xi as the discrete points. So xi, the midpoint or discrete, and that you can multiply by 1. You can take the reciprocal 1 by xi into fi. So f1 by x1 plus f2 by x2 plus etc. plus fk by xk, if there are k classes, and the formula is capital N divided by summation I equal to 1 to k fi by xi. This is the geometry, where capital N is the total number of observations or total frequency. This is summation fi I equal to 1 to k. This is the capital. Okay. Now we can use some data sets to illustrate these concepts. The first case 248 as the raw data here. So harmonic mean is 3 divided by 1 by 2 plus 1 by 4 plus 1 by 8, that is equal to 3.43. In case of a discrete data, xi is 248 and fi is 231. So can harmonic mean equal to 6 divided by 2 by 2 plus 3 by 4 plus 1 by 8, so that they can compute it as 3.2. In case of a continuous frequency distribution, here there are class intervals 0 to 10, 10 to 20 and 20 to 30, and frequency corresponding 4, 6 and 5. We can find the midpoints as we did earlier, 5, 15, 25. Now the harmonic mean can be computed using this 6 plus 5 plus 6 plus 4 plus 6 plus 5 is 15. 15 divided by 4 by 5, this 4 divided by 5 plus 6 divided by 15 plus 5 divided by 25, and and can get it as 10.7 as the value. Now, two things we have to two important matters as merits and demerits of geometry. In case the geometric mean handles skewed data well, that's a first merit of the geometry. Another merit is insensitive to extreme values, is less sensitive to extreme values, and ideal for multiplicative processes. These are important merits. And regarding demerits, it is not applicable to negative values. Once there is negative value, it is not possible to define geometry. And for it is more complex to compute. Nowadays there are computers, so it is not much complex, but in usual way it is not easy to compute. And another demerit is less intuitive interpretation is another matter. And regarding harmonic mean, the merits are is ideal for averaging rates. First, this is ideal for averaging rates. Less influenced by large values. Mathematically sound for reciprocal relationships. These three are important merits, and demerits is not suitable for zero values. Once the one of the data point is zero, it is difficult to compute, becomes infinite. And less is sensitive to small values and less intuitive. These are the important demerits. Thus, we have defined geometric mean and harmonic mean, and how we discussed how to compute these measures as an alternative measures of central tendency. Geometric mean is useful for multiplicative relationships and skewed data. Harmonic mean is ideal for rates and ratios. Both have some specific limitations and merits, advantages also. Okay, thank you so much.